So I'll just kick things off, and I want to thank you for the invitation to talk today about some research that was a part of my dissertation, and I'm still trying to find a home for it in a publication somewhere, but I'll give you guys the inside scoop. So I'll foreshadow a little bit of some of the results that I want to talk about, and obviously I'll unpack these. And so the first sort of assertion that I want to make is that scholars of socio-technical collaboration have really overlooked the sort of the non-random structures that come from the accumulation of contributions, and that these accumulated contributions that we see on Wikipedia, on GitHub, on SourceForge, on a variety of these sort of socio-technical systems, they trace out these trajectories of users and artifacts, and that if we interrogate these objects, these data structures using network analysis methods, they reveal some really interesting sort of differences and patterns, and that these trajectories are easy to compute, but they have sort of these complex structures and dynamics, and I argue that they generalize across different sorts of systems and analysis. And so the TLDR, as I sort of get into this, is like I want to present a method that feels like it shouldn't work, but it does, and I hope that you'll throw some darts and try to poke holes in it where you will. I want to start off with a little bit different sort of narrative, and I want to start with Eric Raymond's sort of famous cathedral and the bazaar. And so he starts off sort of differentiating sort of the way that we go about sort of large-scale collaboration, and he talks about how he had for a long time thought that these sorts of large-scale important software needed to be built like cathedrals with sort of highly centralized, highly ordered, highly sort of hierarchical sort of systems, but that Linux and the success of Linux really sort of complicated that, and that it was more like a bazaar where it's sort of you had this coherent and stable system emerge, but it was unclear like how this whole process worked when it really shouldn't. And that and he argues that in the cathedral builder, these bugs and problems are sort of very complex, and they can only be solved by months of work by a dedicated few until you can stamp out all the bugs. But he argues that the bazaar sort of model works because you have the sort of what became formulated more as Linus's law, that you've got sort of thousands of people sort of working on each sort of individual version of each release. But I want to say that this idea that there's this difference between sort of the cathedral and the bazaars is somewhat a false dichotomy, or maybe he didn't understand how cathedrals were built. And so if you look at sort of scholars of architecture and sort of socio-technical systems, this is the cathedral at Chartres. I'm not pronouncing, my French is atrocious. But the way that these cathedrals were built, they were built over the course of centuries, and they had different sorts of contractors who worked over decades to build these sorts of cathedrals in like campaigns that took like years of each campaign. And there was no sort of overall designer of these sorts of systems. I mean, a building as complex and beautiful as this is very much a system that sort of evolved over time, but the work of building a cathedral is the accumulation of the work of many men. So this idea of accumulation, that cathedrals are these sorts of large-scale laboratories where the collective work of skilled specialists was aggregated, and in the absence of any sort of central plans. Again, these were built in like the 13th century, the 12th century, before we had any sort of modern understanding of physics and forces and force balance, that these were sort of experimentations that sort of unfolded in terms of what worked and what didn't, but that the local knowledge and messy practices were combined and transmitted in the artifacts and the methods. So it wasn't that people were communicating with each other, but actually the work of these large-scale collaborations was actually embodied in the architecture itself. And if we fast forward to sort of modern sort of peer production sort of systems and aggregations, so Yochai Benkler would argue that sort of peer production works because we're able to sort of pool diverse efforts through modular projects. It makes it possible for people to contribute at different sorts of levels commensurate with their ability, availability, and motivation. And Clay Shirky also similarly argues that sort of the work of building an artifact like Wikipedia isn't a process, is a process, it's not a product. And every sort of contribution to this sort of system is provisional. It can be changed at a later time, but sort of aggregating all this together, combining it is like creating a coral reef. It's the sum of these individual contributions. And so this idea that like the way these systems work comes from aggregation, from accumulation, from the sum of these sorts of micro sorts of processes actually has sorts of biological sort of basis. And so if you go to theories of Stigmergy, And so this is a cathedral that termites built. And so these sorts of structures aren't sort of centrally organized or centrally planned in any sense, but they still have these sorts of large-scale structures that are sort of 5 meters tall. And the regulation and coordination of building these sorts of artifacts is not done through termites communicating with other termites, but termites sort of like leaving traces of their work that then other termites then build upon. And so the self-organization sort of and the incredible complexity that we see comes from sort of simple actions in response to sort of traces left in the environment rather than communication with the central authority. And so I want to sort of bring this idea of stigmergy into sort of human systems and say that stigmergy can unfold in a human context. I'm citing Christensen here, where sort of people are directly acting on the physical traces of work that others have accomplished, and that they're able to sort of create sort of meaningful artifacts, or people are able to encode that into the artifacts that they work on. And so this idea that we should be looking at these artifacts as how they mediate this collaboration, how this collaboration unfolds is sort of really important. And so I've talked about sort of accumulation and the aggregation, all these sorts of things, and so I'll explain what these sort of mean in more detail, but I want to sort of start with the sort of my different research questions. And so if we look at the accumulations of these sorts of contributions within socio-technical systems, like what sort of structural patterns do they have? And so this is a question about the structure of these accumulations. We can also look at sort of what do these accumulations reveal about the dynamics of how these systems unfolded, like how did the structure change over time, or what did these structures, this accumulation encode about changes over time? Then finally, like, how might this method work in sort of different sorts of contexts across artifacts, across users, across multiple levels of analysis? And so I mentioned Wikipedia, and so if we look at something like Wikipedia is sort of built up on top of each other, people making contributions and other contributions are added on top of that. And so in this case, this is Harvard University, and people are making changes, and so in this case, someone adds 133 bytes to the article, and then someone says this isn't even close to being a reliable source and takes it out. And so in some ways, you can see evidence of this, like there's no communication between these people. This person didn't leave any sort of commit notes, but seeing the content prompted someone else to then do some work on that person's content, in this case, removing it. We see this in something like GitHub, where people are merging pull requests and making changes to an artifact. And I'm looking at Bootstrap, which is a very popular JavaScript library. But you see the evolution of this library, this artifact, being like the accumulation of these sorts of tiny little contributions over time. And indeed, even if you look at something like an online community like Reddit, you've got sort of like the top rated post ever was sort of, please ignore this post. But the work of like how this post became top rated was sort of articulated through like all these other people's sorts of comments and people's coming by, leaving comments, and other people leaving other comments on top of those comments. And sort of the reason of this becoming popular is because this became like accumulation of a lot of interest and attention. But all three of these are sort of examples of what I call event logs. And so event logs have a few sort of important patterns or general patterns here. And so one is an activity. There's a system action, so you're making a commit, a revision, or a comment. There's a case. This is the entity that's being acted on. So it could be the specific repo on GitHub, or it could be the specific Wikipedia article, or a submission on Reddit. You have a performer, like who is actually doing this action. It's a user, an editor, a member. Then an order, which is the sort of the sequence of how these things unfolded over time. And it's usually indicated by a timestamp. And so as we saw in each of those cases, you would have something like an activity like a commit made to a case like X, article X, made by performer A at a specific time. And so subsetting on the set of like all case, like everything that's been done to article X and ordering it by time, you can kind of see that like A made a change, and B made a change, and C made a change, and so on. And this has been, and so these sorts of data are sort of well understood and well known. We've understood, it's a large sort of body of literature that's looked at how do we like mine these sorts of data sets to understand how collaboration works, these large scale open source systems, and how they change over time and so on. But these are sort of generally modeled under like an assumption of trying to answer this sort of question, like who works on which artifacts. So user A makes a contribution to artifact X. So like user A makes a commit to this article, or user A makes an edit to this Wikipedia article. And so there's two different kinds of entities in this network. And the result is it's a bipartite network. And so when you look at these sorts of networks, you get these sorts of very nice pictures of you've got sort of like Wikipedia articles in red, and then the editor's in blue, and so you see that there's lots of heterogeneity, and it's a very pretty picture, a hairball, and that some things are very well connected, and others are less well connected, and so on. But this is a question of who's working on all artifacts in the system, but we really don't have a picture of what's going on within any specific sort of artifact, right? And so one way that we might do this under this sort of modeling approach is we would say that at time 1, A makes a contribution to X, then B makes a contribution, then C makes a contribution. A comes in at time 4, makes another contribution. So maybe we make that line thicker, or how do we sort of represent that dynamicism that this A appears 3 times and plays a very sort of central role, but structurally representing this, A sort of has just as many connections to artifact X as all these other articles, and maybe just has a thicker connection. So taken to the limit, if we wanted to look at the structure of a collaboration within a specific artifact rather than across multiple artifacts, the result is we get something simple and trivial like this, you have an artifact and here are all the people who made a contribution to it. We really don't have a picture of what's going on and who's modifying whose work within these. And so if we take a page from theories of process and sequences that is sort of occurs throughout sort of sociology and psychology and communication, but understanding how sort of coordination, collaboration, and communication works through a process of people building on top of each other through a sequence of actions and through developing these sorts of narratives, we get a very different sort of picture. And so the operant sort of relationship no longer is who works on which artifacts, but who modifies whose work. So user B made a change to user A's work. You can imagine that user A passed the document to user B when user B made a change, modifying user A's work, all right? And so on Wikipedia, we would have a picture like this where you would have user Apteva is making these changes to the article about the Boston Marathon bombings. And so in this case, this person had stated the article at one point in time and made some changes to some other part of it. It wasn't actually on this, but his version of the article had the stuff capitalized, but at another time, this person comes by and makes things more camel case. So that's a small contribution on top of someone else on merging a pull request or making a contribution to a repo, that this person is doing a small contribution of changing the U's to the O's in this repo. But then so we want to go back to this event log, and we're how might we build out a network based on these data, that we would say that user B modified A's work, C modified B's, A modified C's, D, A, and A to D, and you would get a pattern like this. Obviously, there's sort of repeated information here. So we could represent this as a graph where A makes a contribution, then B passes it to B, passes it to C. A jumps back in at time 4. At time 5, D makes another contribution. And so in this sort of simple toy example, we already have evidence of a substantially more complex sort of network structure emerging. And so it's important to note that I'm not making any assumptions about they were modifying the same content. They could be working on completely different elements of these articles. It's simply the fact that I'm modifying a version of your article immediately after someone else operationalizes these temporal adjacencies. So it's simply we have a temporal adjacency. I'm modifying your work or some version of the work that you had, even if it's different parts, just simply by editing immediately after you. And so I still haven't made the case that this is interesting yet. So I want to look at an example of the article about the Japanese earthquake and tsunami. And so the Japanese earthquake happens in March 11th, 2001. Wikipedia is a sort of a well-known sort of resource for sort of breaking news events like these in the event. And so looking at this 3 years later almost, we have this article. It's now very complex. There's lots of references, lots of hyperlinks that it sort of is communicating information in different languages and has sort of the transliteration and all of this. And this is just sort of the introduction, and there's all this sort of structured information there. So there's obviously a very sort of complex, and a lot of the work went into this article. And we can see that again, by going through the history of the Wikipedia article, that the first contribution was made on March 11th, and then it was about 45 minutes after the earthquake, and then people start jumping in, making contributions on top of each other. And so NanoBear was the first editor, and the Pristino made it, modified NanoBear's version. This IP modified it the third, and so on. And so the question is, do these have sort of complex structure? So here's a hairball diagram. And so it's a hairball. And so, but if we begin to sort of interrogate this with sort of network analysis methods, we can begin to say something about the structure of this. And so again, the nodes in this network are editors. And so an editor modified another editor's version, who modified another editor's version, and so on. You've got some editors here clearly very central. I made them larger because they're modifying many other editors' nodes and so on. And so, but is this, what are sort of the structural characteristics of this sort of network? So it has sort of the classic sort of like long-tailed degree distributions that we see in many types of complex networks. If we look at 5 different sorts of features of this network and plot those features against a random network that has the same sort of density and number of nodes as our observed network, we see that this network is indeed, the observed network, its values here are in red, are indeed very different from these other networks. So in this case, our observed network, the best connected node is connected to about 10% of all other nodes. And about 10% of all nodes are connected to this node in turn, which is substantially higher than we would see in random networks. We see substantially more reciprocity in this sort of trajectory. So this is saying that if I modify your work, you're going to modify my work in return at some point. So we see about 20% of links are reciprocated in this way. We see substantially higher clustering, which is like we're modifying each other's sort of work at a distance, and that this sort of path length is similar to a random network, but we'll unpack that a little bit. We can also look at degree correlations. And so this is the idea that, like, given that I'm, yeah?
So this, what you're showing is from that Japanese earthquake.
Yeah, so these are all properties of this network right here.
Are these properties similar with other Wikipedia articles?
Yeah, so I'll get to that in a little bit. But so this is just for the single case right now. Yeah.
About the reciprocity.
Yeah.
Is this mostly due to because like we're just editing the article during the same hour, or is it like is there some way to control for this like across time, or is this all within a very short time span?
So these links again are just only occurring because I edit immediately after you, and so some of this is certainly an artifact of people a lot of people just editing all at once on top of each other, and so you get this sort of agglomeration. I do have some findings that are not in this slide that kind of show that there are sort of characteristic patterns where it's sort of one domain, sort of this pattern holds where people are editing in this very highly reciprocal way, and then as time goes on, that sort of pattern of collaboration fades off. Yeah.
When you say random network, are there certain like network structures that you think are a good baseline to make this comparison?
So the claim that I'm just making here, I'm not saying that I would expect these networks to be random, but there's an expectation that this sort of the accumulation of this effort and these sorts of links might just have sort of a random, like the fact that you edit and I edit after you may just sort of be random in general. And so the fact, so I'm just, would then maybe generate a random network under some sort of models. And so if we just use a simple model of random, like an Erdo-Schrödinger network, where just sort of links are just dropped at random on a set of nodes, you would get these sorts of distributions down here in the blue. But we see for the observed network that we're looking at in this particular case is actually has substantially different and higher levels of these particular features. And so there's a question of like, is there a better way to develop these, a statistical model of how this should look like as a valid null model? Absolutely. We can also look at sort of the connectivity or the patterns like local neighbor connectivity, sort of like degree correlation. So this says that if I'm well connected, are the people who are modifying my work themselves well connected versus do the people who modify my work, are they sort of poorly connected? And so we see these negative correlations, which is actually very unusual. We often don't see in social networks. So social networks are usually classified by having sort of positive degree correlations, where sort of well-connected people are connected to other well-connected people. This pattern is actually saying that well-connected people in these socio-technical trajectories are actually connected to poorly connected people. And this sort of negative correlation holds in both. But this is sort of an interesting distinction because we see in other sorts of systems like the power grid or metabolic networks or these other sorts of complex systems, we find these negative degree correlations as well. And they're all. What happened there? All right. We see that, and they're often evidence of sort of like more sort of systems that are highly resilient to sort of attack. And so we see that these particular network features in this trajectory are significantly higher than random graphs of the similar size and density. And these negative degree correlations suggest that you have these well-connected editors are modifying poorly connected editors' contributions, and poorly connected editors are in turn modifying well-connected editors' contributions. Yeah?
So the random graph, the null model,
yeah.
Is that also equivalent to taking the log and permuting it randomly and then mining that network? Is that sort of what the...
So this wasn't sort of a graph permutation approach. This was just like a pure, just you take a network and you fix the density, and then you add edges up until you hit the number of nodes.
Okay.
And so, well, what's important about these sorts of networks as well is they encode important sort of dynamic information. Because I'm editing, these networks are built on these temporal adjacencies I modify after you. They're encoding temporal information. So we can see information about like how much time was elapsed between change, how much someone added, and so on. So I'll just touch on a few of these. And so now we can color the nodes here based on when they joined. And so bluer nodes are editors who started editing this article earlier on in the article's history. And redder articles, as the color becomes more red, they start editing the article. They join the collaboration much later in its history. So you see, let me walk through these here. And so you have the sort of the first editors out here. So these are all the people who are editing immediately after the article was created. And they're modifying each other's work as a matter of course as the article develops. And this is in the first hour or so of the collaboration. But what's interesting is that these are the editors who are the first people to touch this article, but they don't themselves remain engaged in the article itself. They leave. By virtue of them being on the periphery here, their work, they were no longer making contributions. They were no longer receiving modifications from other editors. And so we see that there's a second set of editors who come in at a later stage, and these become much more involved in sort of the editing and modifying each other's work. That's a very sort of dense part of the graph right there. You contrast that with these editors out here, these strings. And so what's interesting about these strings, this is an editor who makes a contribution, then another editor modifies that one, but this editor never jumps back in, and then a third one modifies the second, and so on. So you have these strings of editors of people making contributions on top of each other, yet none of them decide to jump in and modify subsequent sort of work, which is in contrast to this sort of case, which is I make a contribution to your sort of version of the article, and then maybe someone else makes a contribution, and then you decide to jump in at a later point in time, which would be captured more by the sort of dense pattern. But at later points in time, it becomes much more sort of stringy like that. And you have this sort of very central and highly prominent sort of person in the center. And we'll talk about this editor a little bit later in the talk, and this vandal fighter as well. But this previous graph was looking at the nodes colored by their start time when they joined the collaboration. We could also color them by the last time they made a change to the article. So if you make just a single article or a single contribution, your start time and your stop time are the same. But if you keep making contributions over time, your start time and your stop time will be different. So again, bluer are people who stopped editing earlier. Redder are people who stopped editing later. So again, you've got the cluster of people who started editing early and then stopped editing almost right away. You've got the people who joined a little bit later and were very involved in it, but a lot of them, sort of this blue background, they also stopped editing immediately. But you've got these reds right here who are essential but are at a different point in time in the article. But if you kind of contrast that, they were also kind of joined very early. So you've got this editor sort of joined very early, but also left very late. They were very involved in the editing of this article. And indeed, the central person here joined relatively early in the article's collaboration as well. They were blue, and then they kind of left at a green. So they also left relatively early as well. And so we can also, these links, like I said, these temporal adjacencies, they say how much time has elapsed since I last edited the article. And so we can look at links that are less than 60 seconds old. So this is people who are making changes within a minute of someone else making a change. And so obviously when the article is very early, we see we see a lot of those sorts of links. In much of the rest of the article, those links drop away. That obviously, like links, this content is allowed to persist for over a minute, thankfully, before someone else makes a change. We also see this editor right here who has a sort of star-like pattern of lots of links that are less than 60 seconds old, and that's actually a vandal editor. So like as soon as someone puts in something awful or vandalism of any sort of type, this editor is jumping right in and undoing that within 60 seconds. It turns out that editor's not a person, it's actually a bot, but that's a story for another time. But then if we, again, subset the network again and look at just the nodes who made contributions of just more than 50 bytes, like who's actually writing like more than a sentence worth of content to these articles, the network disappears, and you just have this sort of this interesting sort of backbone that the central person, these highly connected nodes, these people who you thought were very sort of well connected and very sort of important under one metric disappear. And if you're actually asking a different question of like who's actually writing content. And so a lot of the content that's actually being written, these long, like anyone writing more than a sentence really, there are lots of these sort of small peripheral sort of people. And so this suggests that the people who actually do the writing of the article, like jump in, write their sentence, and then jump out and don't stay involved in it, and then leave it to everyone else to sort of figure out and work out where this should sort of occur. And so I mentioned that these were just sort of, this is the one case study looking at just the Japanese tsunami article. But obviously, if we look at sort of, you can apply this sort of method to any Wikipedia article, and you would get sort of variation in sort of trajectories that look like this. So you've got like networks that look like more like traditional sort of complex networks, that they're sort of hairball-y, right? That they're sort of dense, they're clustered. There's a strong core. There's a periphery there's a core of well-connected nodes. There's a periphery of like poorly connected nodes. In contrast to networks down here, which don't look like networks you ever see of any kind anywhere sort of in the world. These are not networks that we can even sort of model that well because they don't behave. That this is a case of one editor makes a change, then another editor makes a change, and the third, then a fourth. But all the early editors never decide to get involved again. So these sort of stringiness. So using a very technical term, I'm going to call the top one more hairball-y than the bottom one, which is less hairball-y. Yeah.
So is there a relationship with regards to the time at which the event is occurring and the amount of edits or the amount of text that's being added to the article? Do you have any measures of that, or have you looked at that?
So I have looked at that. Won't be able to get into it in this talk, but it's certainly the case that, and this is other things that I looked at with my dissertations, where I looked at how old an article was when these different sorts of patterns were sort of unfolding. And it was the case that when an article is very sort of young around these breaking news events, that like the article about the event is being written as the event itself is unfolding, about an airplane crash, about an earthquake or a natural disaster, that you see these dense patterns very early on, that they disappear over time. And so again, so just using the sort of very sort of technical term of hairballiness, the ones on the top are more hairbally because they're clustered and they're dense. They have short path lengths, like it's easy for people to reach other parts of the network, conditioned on the size of the network, versus this person has to go through everyone else to get to the other one. So this is a long average path length, low density, and so on. So let's look at some examples of differences. And so if, in terms of quality, and so if we look at sort of 25 articles about topics in medicine who are sort of rated by Wikipedians on sort of four categories. So featured articles are sort of like the best that Wikipedia offers. These are the best articles in Wikipedia. Good articles are sort of just as good. Both of these go through a very sort of stringent peer review process to be sort of elected to this set, to this label. B is sort of like, it's most of what you see in Wikipedia, and C is sort of like pretty bad. Maybe we should get involved in making a change because it's kind of bad. But if we want to compare how sort of these different sorts of metrics, these network metrics, compare against these different article qualities, again, I'm not making the case necessarily that these network properties cause them to have these sorts of quality metrics, but that there's interesting differences between articles and their quality. And so high quality articles have more clustering than poor quality articles, that they're more hairball-y. So higher quality articles have more hairballiness than low quality articles. That high quality articles also have higher levels of reciprocity than lower quality articles. And that the shortest path length, that higher quality articles have shorter path lengths than lower quality articles. And so across all of these, we see sort of evidence that we're capturing something important about how the patterns of collaboration, the way that we generate this content, actually has sort of a meaningful impact on the quality of the collaboration and what they're producing. That more hairballiness sort of generates higher quality articles. That's a very strong causal language. So we see that these trajectories reveal very interesting dynamics about editor involvement, when they get involved, when they leave the collaboration, and at what stage of the article history they're doing this. And that we find that these sorts of these metrics actually have some interesting correlations with the quality of the collaboration as measured by other sorts of metrics. And so we've just talked about Wikipedia articles, and I want to talk a little bit how this method might sort of generalize to other sorts of contexts. And so again, if we looked at something like a GitHub repo of people making changes to a GitHub repo, we saw an example of this before, but how might we generate sort of artifact trajectories based on this? And so this is for the Bootstrap repo. So again, every node here, every circle here would be an editor making a change, and then they have a link to another one if they're modifying that user state of the repo. And so in this case, you've got two blue editors. So these are the original sort of co-founders of Bootstrap. And then, so they're blue by virtue, again, of them sort of joining the collaboration sort of very early. And then you've got these sorts of other sort of editors in these large circles, or sort of orange or red or yellow, or so they join much sort of later. So this is telling us a story about, like, you've got sort of two core contributors who are sort of editing each other's work sort of very intensively. But this repo actually is sort of highly centralized. And so it's like someone makes a change, and then this person jumps immediately back in. Someone makes a change, and this person immediately sort of centralizes it. And the colors of these links, again, are meant to sort of evoke the time elapsed. And so blue sort of links are very sort of rapid changes. So this person made a change immediately afterwards, or this person, the central person, reverted that change very sort of quickly. Versus the redder sort of links are sort of changes that were allowed to sort of persist, that a long time went by before another editor jumped in. So this is a sort of very highly centralized one. So this is kind of telling a story. And indeed, you can look at sort of both the accounts of how Bootstrap was evolved and how people joined and left the project, but sort of two core contributors sort of intensely modifying each other's work, then other people joining. But they remain very central hubs throughout. That, and in contrast, if you look at a library like libgit2, this is a really sort of fascinating one. We've got the initial creator of this repo all the way out here in blue, made some changes to himself, and then weeks, months went by, and then another editor jumps in and modified his work. And then months went by, and a third editor jumped in, and then maybe weeks instead of months, this person jumps in and starts modifying his work. And then you get to sort of this green right here, and this person becomes a very sort of important broker and takes the library in a way, or connects it to another sort of community, where it then just sort of explodes into this like highly sort of active level of collaboration, where it doesn't have the sort of same level of centralization. There's no sort of central actor here who's like at the core of this, but you've got all these actors who are sort of very densely sort of interacting with each other and modifying each other's sorts of work. But these are mostly sort of pretty pictures.
Interesting. I think it's kind of explained by your graph there, because after Microsoft started supporting Git, like a lot of their developers actually jumped in on this library to like improve the Windows support for it. So like I don't know if you know, like this, like there's no temporal information there, but it's like there's like groups of people that kind of latch onto this and start.
Well, there's temporal information in the sense that these are sort of the earliest editors who were barely doing anything, and then at some point, if this is like the Microsoft user who like began to say like, oh, this is a great library, let me introduce it to the rest of my team, and then all of a sudden we have this sort of distributed collaboration unfold, and then they're working very intensively on it. They get these blue links that they're modifying each other's work sort of very rapidly on top of each other, in contrast to like languishing here for like weeks or months. So it tells a sort of very different sort of story, but that's definitely very interesting. So what we've talked about have all been sort of artifacts, like looking at Wikipedia articles, looking at GitHub repos, but we can also apply the same sort of idea to user contributions. So in this case, this was my history of contributions to Wikipedia at one point in time. And so we could apply the same sort of metric and say that rather than, if we subset on me as a performer, or any user as a performer, and look at the progression of all the commits and changes that this user made over time, again, you get a sequence that looks like this that you can represent as a graph. And so if we wanted to go back and ask who was that central person here, like who was that? What was he doing before? What was he doing afterwards? What was he doing during that time? So there was someone else who was a bot, but this person was an actual person. And so the first contributions that he or she made were to this Tucson shooting, so about the shooting about Gabrielle Giffords. And so his first evidence of making changes to Wikipedia, he's very sort of involved and motivated to make changes about breaking news events because he was making changes to this Tucson shooting article. And then he kind of like flows off and starts making changes to things about mobile phones, and it's like editing stuff about Antarctica and like the lowest temperature ever recorded and some other articles. So again, these are the nodes are articles, and a node is connected to another node if that editor edited the other article immediately afterwards. So he edits the Tucson shooting, and then he moves on to editing mobile phones. Then he moves on to editing articles about Antarctica and the lowest temperature. Then he comes down here, and then his whole pattern of how he's interacting changes considerably. He starts off editing the article about the earthquake and tsunami, which is indicated in the sort of blue color. So these blues are the Wikipedia articles in the main namespace. These are the articles that we all read, like the front pages. In contrast to like these purple or colors, which are sort of talk pages. These are talk pages, so they're trying to like talk user to user about something. So he comes down here and starts making a ton of changes to this article. He's talking to lots of other users about it. He's talking in the green and the brown. The brown is sort of very technical pages on Wikipedia that most people never see. So we see in this like an evidence of like this person who's initially very interested in the Tucson shooting, sort of like wanders in the wild for a while, becomes very involved in editing the article about the earthquake and tsunami, and then just stops. And it turns out that if you look at this effort, all this effort that you saw here, this all unfolded over a period of about 2 weeks. But there were several periods in which this user made a change like at least every 10 minutes over the course of 56 hours. So this person was doing an absolutely like superhuman amount of work over the period of just a few 2 weeks, and maybe it was just burnout or what have you, but this person leaves. And so this has some interesting implications for, did this person get burned out, and should we prevent people from burning out if we're trying to attract and retain new Wikipedians or new users in sort of these systems in general? But this sort of lets us sort of illustrate and narrate like how a person's changes over time have happened. In contrast, we can look at someone else who is also very active on the articles about the nuclear disasters that happened around that. And if you look at this person's history, it also tells a very different sort of story, that this person is very involved in editing articles about Harry Potter before they jumped into editing articles about the nuclear disaster and related topics. Then they jumped down to editing an article about Cutty Sark, which is a kind of Scotch or a name of a famous boat in the UK. But what's interesting is that you see the most central articles here aren't those sorts of blue articles, which are the sort of the front page articles. You see a lot more of the green and like the light blue. And so these articles are, or these types of pages aren't the articles that we see on, but they're actually like discussion pages. They're actually like the administrator dispute sort of boards and these sorts of things. And so this person is actually like an arbitrator of disputes. And so on the Harry Potter articles, this person was very much involved in like, oh, the new book came out, like should we reveal the spoilers or not? And this person's like playing a role and saying like, oh, these are our policies, these are our rules, this is how we do things. And as a result, they're not editing the content of the article that most people read, but they're very involved in the collaboration of making sure everyone's playing along nicely. And indeed, it's also the case in this article about the Scotch or the boat. So this person is able to migrate their expertise and their experience from one sort of context about Harry Potter to editing articles about nuclear disasters, which in most sort of traditional organizations we would say like, no, people who edit articles about Harry Potter shouldn't be editing articles about nuclear disasters. Yet in Wikipedia, you have this openness and flexibility that we're allowed to people are allowed to migrate that ability to be arbitrators and dispute negotiators and things like that from one domain to another domain. Potentially is a very sort of interesting case study. And this is my favorite. So this ACSC was sort of very involved in articles around the nuclear disaster as well as sorts of all the towns and the cities. And if you look at his history, it's like all blue. Like all he does is edit articles that we see. But the topics of these articles are interesting because it's about like Japanese pop bands and serial killers in Japan. So this is clearly someone who lives in Japan or grew up in Japan or knows a lot about Japan and plays a sort of very crucial role. Again, they're migrating their expertise about Japan and popular topics and popular issues in Japan to editing articles about all the towns and cities that were affected and wiped out. So the work that this person was doing was that, oh, the tsunami hit this baseball stadium, like we should update the article about the baseball stadium to reflect this new information. And so you need to have these sorts of people. So again, would you want someone who's editing articles about Japanese serial killers or pop bands editing your article in your organization about some late breaking event? Most people would say no. But in this case, you would be missing out on this opportunity for someone to be able to migrate that expertise about this particular cultural domain and update that and bring that in. And then so finally, we've only been looking at this as like a single level of analysis, like only a single artifact at a time or a single editor at a time. But we can imagine we can begin to create like a multi-graph where you've got two of the same editors, editor A and editor B. They actually may work and modify each other's work on different articles. And in that sort of case, we can represent this as a multi-graph where you've got, again, sort of editor A and editor B, but they would have, you could define two edges that exist between them. And then you could even collapse that down and say something about the types of those articles that they work on. So if these are both breaking news articles, where I mean a breaking news article, this gets to your question, is that if an event happens, like a tsunami or something like that, do they begin editing, and do they create an article about that event within 24 hours? So like the event happens, does an article get created in the next 24 hours or not? And so we can look at that. And so if these editors work across breaking news articles, that they work on one breaking news article, they work on a second breaking news article together, we can represent it as a graph, like as an edge like that has weight 2, reflecting they worked on 2 articles, and the color red represents that like all the articles they worked on are breaking news articles. In contrast, we can imagine that you've got the same 2 editors, and one article is a breaking news article, they work on it 24 hours after the event happens, versus they work on it after the 24 hours. You might imagine, again, do the same sort of multi-graph approach, define 2 edges, but the edges are sort of substantively different types, and you might aggregate that and say, again, an edge of weight 2, but then you might color it a different way to say that it's green because it's 50% of its breaking versus 100% of their interaction is in the context of non-breaking or breaking articles. So the result is you would get a graph like this. So again, the gray nodes are all editors, and they have a link to another editor if they worked on 2 or more articles together. They've modified each other's work on 2 or more articles. And we're going to color the links, again, based on bluer links will be like, was more of that work done in sort of traditional sort of collaborative context, so like working on non-breaking articles? Or was this done more like, were they working exclusively together on these articles about breaking news events? So these are all, I looked at sort of 3,000 articles about natural disasters and technological accidents and plane crashes and lots of happy subjects like that. And so across these sorts of 3,000 articles, you get this set of editors who've modified each other's work on 2 or more articles. And you see that you've got sort of the strong core of these reds. So these are people who are working together across multiple articles, modifying each other's sorts of work. So you've got this community of people who are working to like modify each other's work. Sure.
Maybe I missed it, but you, in this Japanese example, you also assumed that the person knew a lot about Japan and the culture, but I think there's been other research on Wikipedia where it's actually been the people who edit a lot just edit text edits. They don't edit the content. And did you take that into account?
So you're absolutely right. That is the case, that there are people who kind of just exist to like make lots of edits. And so those people will absolutely show up in sort of things like this. But what I suspect you won't see, so those people will show up, but they won't be so central because they'll be moving across multiple different types of articles. What we're trying to capture here are people who are very involved in editing one article, that lots of people are trying to make changes. And after those people make their changes, I come in and try to make my change again. And so we've got these people who are trying to accumulate 1,000 or 10,000 or 100,000 or a million edits. Like they're just going to be working across thousands of different articles, and so they might be more on the periphery of these kinds of collaborations than in others. But it's a good point that you do have these sorts of behavioral sorts of heterogeneity in terms of what's motivating people to make these sorts of changes. But what we're capturing here is there's a core of editors. These are sort of like the journalists on Wikipedia who exist to sort of, they work together across multiple articles and they're modifying each other's work. And this work is exclusively occurring in the context of these breaking news articles. They only work together in the first 24 hours of this event. But then we also have, there's some blue here. There's people who work together on non-breaking articles like you would expect. There's like, these 2 people seem to work together a lot. And then you've got this sort of interesting sort of blue-green color down here. That's green-yellow, rather. And so these are all editors who belong to this project called Wiki Project Tropical Cyclones. And so this is a wonderful example that I love, is that these are people who kind of like, they're like basically like meteorology buffs. They just love writing articles about hurricanes. And they write about them like in a very sort of scientific way. They just exist. They want to just write a Wikipedia article about every hurricane that's ever existed. And so they go through from like 1934 all the way to like the present, and they're just documenting every sort of hurricane that's ever existed, trying to write an article about all of them. So they're working together across all these different hurricane articles because they care mostly about hurricanes, but obviously some hurricane articles are things that happen in current events, and some of them are sort of just historic events. And so as a result, you have these sorts of strong green-yellow ties. They're working on a mix of breaking and non-breaking articles, yet they're sort of apart from the rest of the collaboration, that they're not working on them because they're breaking news articles like these editors are. They're working on them because it's a coherent topic. This is a community of practice of people who are united by sort of a common sort of identity and common interest to write about these breaking news articles, but they work across different sorts of contexts, both breaking and non-breaking on these together. And so we can take from this that these sorts of trajectories can be applied to other systems like GitHub, that these trajectories can reveal the structures and these editors' contributions, and we can look at them as editors and how their interests and their expertise and the roles that they've assumed have changed over time, and how they've moved through the different sorts of collaborations within a system, and that we can begin to use some more advanced sorts of network representations and structures to create the multigraphs, to say that like there's editors who are overlapping, these trajectories can overlap in these ways, and they reveal these communities of practice, these people who share common interests and modify each other's work across different sorts of contexts. And so just to wrap up here, that these event logs, I argue, are sort of ways to narrate changes to artifacts and changes to users over time, that these event logs encode sorts of stories that are often sort of missed by just looking at them in a traditional sort of way of looking at collaborations. But by bringing in these sorts of temporal adjacencies, these ways that we modify each other's work, that we build on top of each other's work, that we accumulate on top of each other's work, we reveal these sorts of very interesting and non-random sorts of patterns. And that these temporal adjacencies, they collect these sorts of large-scale sorts of event log data, which encodes sorts of important sorts of structure in the time, that the fact that I edit after someone else is actually a very sort of important relationship that has been largely missed, I argue, in lots of previous studies of collaboration. And we were able to create networks and that have these sorts of very interesting sort of non-random structures to them. And that by looking at these networks, we can begin to sort of bring this sort of idea of Stigmergy, that the accumulation of these efforts are very much non-random, that we need to begin to understand and like develop theories and methods and models about how we sort of create these sorts of non-random accumulations. That's just something that it's very sort of interesting, but I haven't sort of provided you any sort of like strong sort of statistical model or anything of how this works, but no one has. This is sort of just a descriptive account, but they nevertheless expose these regularities and these anomalies, the fact that there are these heterogeneities, these differences, these things that don't work, or the things that people behaving differently than everyone else, invites you to go in and like use mixed methods, to use qualitative approaches to say what's going on here, has this sort of quantitative data sort of revealing something that we should look at another way, and that we can begin to use these to study these things that are very sort of central to sorts of social science about how do we study implicit coordination, how do we study sort of how we adopt a social role, how do we understand the communities or embeddedness and how those communities operate, or how we do the work of our organizations. So with that, I want to thank you, and you can hopefully find copies of papers related to this on my website. My website got sort of hacked, so I've tried to rebuild it over the weekend. But there's also some code on my GitHub here that will help you create some of these sorts of trajectories from Wikipedia data at least. So thank you. Yeah.
Meaning kind of like hubs and authority, meaning someone started working on an important subject, insert some important editing, so that person becomes important, and then starts working on something else which is not conceived as important, and so that subject becomes important, etc., etc. So it's like...
Yeah, so you could definitely see, so there's a way that you could imagine taking a user trajectory, so like the set of all articles a user worked on, and then you might imagine imposing, like again, another different kind of multigraph, where you say you take the hyperlink network of all these articles, do they themselves link to each other, ascribe some importance to the different kinds of nodes, and then like look at whether or not people migrate towards more influential articles over time or away from more influential articles over time. And that would lead to these really sorts of interesting ideas about like, do they some sort of expertise about how these articles should be written, or do they have some sort of technical expertise about graph theory or about statistical models that they're able to sort of like help transmit that knowledge from one area of Wikipedia to another. So I mean, that's an excellent question, and I think that using like a method like that, you can begin to interrogate something like that using exactly that. Yeah, that's a great idea.
Maybe you said this earlier on, but have you looked at whether there are relationships between the edits with regards to the content? So if I make an edit and then you follow me with another edit, are there relationships between the type of content that you add, or are you actually editing the content that I made, or are you just adding some more content?
Right, so this method's agnostic to all of that. It might be that we work in completely different sections of the article. And so this is where I come from, is saying this shouldn't work. The fact that like we're working on different things would seem to say that like you may be working on one section of an article or one part of like the code, and I make contributions after you on a completely different part. Substantively, we're not like working together, but yet at the same time, something about the work that you do, like aggregating these things together, like, so in the limit, those sorts of random contributions, I might just happen to edit after you, or you happen to edit after me. Like in the limit, like there's going to be some random noise here. But what I think I try to demonstrate here is there is something about the work that you do more often than not prompts me to do some other sort of work in response. That I recognize that there's something else that needs to be changed. But we can absolutely bring sort of more like sort of the content stuff into that and look at those sorts of changes at the content level. And I haven't done that here. But other people have done work, but it's much more sort of computationally hard to actually go through and code up, like what are the actual elements of a code or an article that someone owns or is responsible for and then is modifying at the sort of content level. So it's computational, sort of tractable, but it's not as sort of efficient as this sort of way, but it would be interesting to do that sort of comparison.
It seems to me that one good application of your research could be recommending articles for Wikipedia editors. Does Wikipedia do any recommendations?
There is some like recommendation system. I think they use both sort of traditional sort of clustering thing that you've edited this sort of set of articles and other people who edit this set of articles edit these other articles. There's tools that exist for that. What I think is more interesting is that you can think of something like Twitter following lists are in some ways, there'll just be a string. You can't like follow someone twice or anything like that. But like the fact that like there's a set of people that you follow and you followed them in a certain sort of order, and you can take the set of people that I followed and I followed them in a certain sort of order. You can imagine you could begin to collapse and like aggregate those together, and like are there patterns, and like I always follow, like someone always gets followed after someone else. You could imagine building a recommendation like system on top of sort of mining these sorts of temporal adjacencies and these other sort of socio-technical contexts. Just the fact that maybe I always follow you, or people always follow you after they follow Oren, because that's what the system recommends or something like that. But I think it's a potentially really interesting way to sort of build out another recommendation algorithm using these temporal adjacencies. Yeah?
How this model will be applicable for internal networks for the companies? Like we using tools like Curator or Splunk, and we collecting gigabytes, terabytes of the logs, and we would like to find out how to detect, for example, botnet on our network, or command and conquer center that it's sending us all the data out to the specific IP address around the world. I mean, so are collecting all these logs, we're collecting flow data from the switches, net flow logs, and we correlate with the secure algorithm, with the intelligent algorithms to tell us the meaning of that behavior. But it seems to be your part would really great fit in this schema that we have right now.
So are these systems meant to be like the accumulation of sort of work like that, or is it just sort of packet switching, or like email sort of network, or what's the kind of network?
Two types of the logging. Logging directly flows from the switches. Every connection, when it's built up within any two IP addresses, it's established flow. Practical information, who was the source, who started connection, who finished connection, what was the IP address, which ports have been used on the layer 4, on TCP layer. We get all this information. We're collecting them, hundreds of millions of them, in the central logging server, right? And then, and then we use at the same time from the servers, the syslog. We're sending from hundreds of the servers, we're sending logs toward the same system. And then the algorithm that is integrated in the software connects dots between flows and logs, and giving us some type of the information what's going on the network, how we can prevent security attack before, make
something
proactive.
So like maybe like the sequence, like so the way I would think through that would be something like the sequence of like IP addresses that a given node sort of visits or something like that would potentially be something you could use for like anomaly detection to say that if I visit...
Behavioral analysis, like one IP address hit 100 times, try to guess password. That's behavior.
Yeah, certainly. I mean, so I would be more interested in like the question of like if a particular, if I had a whole system that if certain like IP addresses are trying to get visited in a sequence like very quickly, if you saw that happening over time, that would seem to indicate some sort of anomaly that we should sort of try to build defenses that maybe those are sort of high risks, or that this is a particular strategy that they're always getting visited in this particular sequence.
But from this all data, I think your software will be able to visualize what's going on.
Yeah, definitely.
And maybe help at least people like me. I'm working as a security officer here at CSCW, that I see actually the sources of the biggest security problem to CSCW or to school.
Sure.
Or to environment, whatever it is.
Yeah, definitely. We'd be happy to talk about that more. Yeah.
I mean, it makes sense.
Great. Yeah.
So have you found that, say I was to take like the graph of the log data, and say like I chop off and I take only the first 20%, and I look at that graph, can that be predictive of the final graph? Have you sort of looked at that?
So yeah, I've got something like that here. So this would be like the graph in like the first 12 hours. And so it would be something like, again, this is like the highly core essential person. It has sort of characteristic core periphery structure. And then you look at the set of editors who are making changes after the next 7 days, and it has a sort of very different. Again, this is in the context of this breaking news article where the norms of collaboration is sort of very different. But I don't know that, I mean, it's a great idea that like, is there some sort of fractal pattern to this that like it just self-replicates, it's self-similar to each other like as the collaboration grows? It's a really interesting idea, yeah.
Or I guess, yeah, just in general, anything could, just maybe even a coarse clustering of the early graph be tell me something about, I don't know, the amount of activity in sort of the later graph.
Yeah, I mean, that'd be really interesting, definitely. Great. All right, thank you all.